Alright, round 1, 2018. This is the BC test. Let's go. Alright, if y equals this, then y prime, well, this is low-hanging fruit. So I'm just going to rewrite that as x times 2x plus 5 to the 1/2. And then I'm going to do the product rule, because that's how you take derivatives. Derivative of the first times the second plus the first times the derivative of the second times the derivative of the second. Then there's chain rule in there. And it looks like they have got a common denominator of this. Right, so I'm going to have to do a little simplifying here. And I'm going to go back to writing it with square roots. That's the square root of 2x plus 5 plus the 1/2 and the 2 cancel out, so it's x over the square root of 2x plus 5. So when I get a common denominator of this, I'd have to multiply this top and bottom by that. And that's equal to 2x plus 5 over the plus x over the common denominator. So it looks like A. So it's pretty easy, but then a little algebra there. Whatever. Hey, do you remember that the derivative of e to the x is e to the x, of course. The derivative of something else, some other number to the x, is that number to the x, but there's a little adjustment factor that you have to make, which means that sometimes if you're looking at something and you're supposed to take an antiderivative, there's only 4 choices here, so you could just kind of run through these and see which one is going to do the right thing. So if you know this, then you realize that if you're taking the antiderivative, you'd have to divide by natural log 2, because that's a different base. So that's C right there. If you're going to get that one, you're going to get it pretty quick, I think. Here, this is, calculus teachers love these little functions, something over the absolute value of itself, because they have, they make natural little step function things. So when x is bigger than -7, then this and this are exactly the same thing, because they're both a positive version of the same number. And when, that's at 1, right there. And when x is less than -7, this is negative, and this is the positive version of the same number. So if you think about like -8 plus 7 is -1, negative is the absolute value, so it's always going to be -1 when you're down here. So that's what that looks like. It is not defined at either end, because you get 0 over 0. What's the limit as x approaches -7? Well, it's 2 different things on the 2 different sides, so it is non-existent. That's D. So watch out for that little function. It's popular among calculus teachers. So how about this? Well, the only way this is going to work out is if we can do some kind of U-substitution. And it looks like we've got a chance here. So we'll make u equal to x to the 1/3 minus 4. So du is 1/3 x to the -2/3 dx. There's my x to the -2/3. I'm going to move that 6 from here to the outside. And then I need a 1/3 on the inside. So I'm going to put a 3 on the outside. That's how I'm going to balance all that. So now I got a 3 and a 1/6 there. And then my inside turns into u to the 5th. And then everything else, 1/3, x to the 2/3 on the bottom, and the dx, everything else just turns into du. And that's how you clean that thing up. And the antiderivative of u to the 5th is u to the 6th over 6. And then I got my 1/2 there, plus c. So it should be 1/12 times that original x to the 1/3 minus 4 to the 6th plus c. That looks like answer choice A. During an evacuation drill, people leave a building at this rate, given here, where t is the number of minutes since the start of the drill. Selected values for the rate are shown 5-minute intervals using a right Riemann sum with 3 sub-intervals. What is the approximation of the number of people who leave the building during the first 15 minutes of the drill? Okay, so right Riemann sum. That means this is how wide the rectangles are. They're each 5 minutes wide, and then I'm going to use the right endpoints for each rectangle, right? So I got 5 by 100 plus 5 by 75 plus 5 by 55. And you can handle that however you want. 100 plus 75 plus 55 is 230 times 5 is 1,150. What's the sum of this series? If you're going to actually find the sum of a series, 2 possibilities. Either it's geometric or it matches up to like a number plugged into a series that you know. So first thing is just kind of sniff around and see if it's geometric. Are we multiplying by the same thing every time to get to the next term of these? Yes. So it is geometric. So first term over 1 minus, looks like the multiplier is negative 1 over e. So that's pi over e over 1 plus 1 over e. They don't have any complex fraction options, so I have to do a little simplifying. Multiply by e over e to get rid of these denominators, and I get pi over e plus 1, which is answer choice B. Number 7, if f of x is this, then what's the limit as x approaches negative 1 of f of x minus f of negative 1. So we need to recognize here that this is the definition of the derivative f prime of x at negative 1. It's the definition of the derivative. This is the definition of f prime of negative 1. Right? There's that slope thing. So, I mean, you could L'Hopital. Well, let me do it real quick that way. If you recognize, this is the best way to do it, to recognize that it's definition of the derivative at x equals negative 1. So that means that, let's see, f prime of x is equal to 3 times x squared plus 1 to the second power times the derivative of what's inside, which is 2x, and then plug negative 1 into that. Negative 1 squared is 1, plus 1 is 2 squared times 2 times negative 1. So it looks like negative 24. The other way to do it would be L'Hopital. Once you recognize that this is 0 over 0, you can say, well, let's see, L'Hopital says I can take the derivative of the top, so that's f prime of x minus, like, whatever this is just a number, right? So when you L'Hopital this, that just goes away. And then on the bottom, so this one is 1. So yeah, sure enough, that just turns into f prime of negative 1 too, doesn't it? So one way or another, you got to find f prime of negative 1. Definition of derivative or L'Hopital. The graph of f double prime, second derivative of the function f shown above, which the following could be the graph of f. Well, there's different ways to think about this. If this is the graph f double prime, this looks like an x squared kind of function. So if this is the second derivative, then the original function would have had to be like x to the 4th, right? If you're going to take the derivative 2 times and get x squared. And this is upward opening, so it's going to be It's got to be D. You could go through and say, okay, well, this is something that's positive here, so it's got to be something that's concave up to -1, and then, or somewhere in there, concave up, and then it's got a stretch of being concave down. Sad face, oh no, he's so sad, he's concave down. And then happy again. So that would match up with that. That's another way to think through that. This function here is concave down and then concave up. So it would have to have a second derivative that looked like that. So anyway, however you want to puzzle through that, it's D. Number 9. Let y equals a differentiable function, so that's got x's and y's in it, so that makes me think probably a differential equation, but actually no, they just want a tangent line. So to find a tangent line, we need a point, which is the point 8, 2, and we need slope. The slope at the point 8, 2 is equal to its x over y, and that would be 4. So the equation for the tangent line would be y minus 2 is equal to 4 times x minus 8. And then the approximation for using this tangent line at 8.1 would be, I'm going to add the 2 to the other side, 2 plus 4 times 0.1, which is 2.4. That's answer choice C. Number 10. This series converges to which of the following? Well, what does this look like? You could, I guess you could just kind of try these and see what works out to be this. I'm a calculus teacher, so I think I'm like probably better than you are at spotting these, maybe. It is this one here. But how do you get there? Well, let's look at these different ones. You should know this is all sine, cosine, and e to the x. Those are series that you absolutely need to know. So quick review of that. Sine of x that's odd, right? The sine function, so it's all the odd stuff. And we're not going to need more than 3 terms to figure it out. And then cosine x is the even one. And then e to the x is the one that's got everything. Like that. Okay, so what's the cosine of x squared? What would that look like? Cosine of x squared is, just plug x squared into all those, right? This is like making a series out of a series that you already know. It's a trick that you need to be comfortable with. And it would be x to the 8th factorial, and then sine of x squared would be x squared minus x to the 6th over 3 factorial. And so if we add those together, does that give me, let's see, that'd be 1 plus x squared, so that's already a bust, minus, so it's kind of close, but it doesn't have the signs are not correct. How about 1 minus x times the sine of x? So x times the sine of x, that series is x squared minus x to the 4th over 3 factorial plus x to the 6th over 5 factorial. So the powers in the factorials don't line up right for that one when you do 1 minus that. 1 minus x squared, that part's right up to there, but then it starts to fail to match up after that. Is it just the cosine series? No. Is it this one? Well, it's the only one left, but just to convince ourselves, e to the negative x squared. So we're plugging negative x squared in everywhere that we see an x. Minus. So that's it. And I'll stop the video there.